Hello students, in this video we have 6 illustrations of chapter 7 alternating current. The question is, a resistor of 200 ohm and capacitor of 15 microfarad are connected in series with the source of 220 volt 50 hertz. Calculate the current in the circuit, calculate the voltage across the resistor and the capacitor. Is the algebraic sum of this voltage more than the source voltage? If yes, resolve the paradox. Very interesting problem. Let us start with calculations, and before that data collection. So what we are given is R value 200 ohm, C is 15 microfarad. Better to convert it into farad, so 15 into 10 is to minus 6 farad. VRMS is 220 volt and frequency given is 50 hertz. What we are asked to find out, current in the circuit means IRMS, voltage across resistor, voltage across capacitor we are asked to find out, and we have to find out VR plus VC also, and then we have to compare it with VRMS. So let us start with finding out angular frequency. You can do it in this step itself if you don't want to calculate it separately. I'm calculating it separately. Let me give these numbers 1, 2, 3, 4. So, angular frequency of the source is omega, which is equal to 2 pi f. You can substitute values and carry out calculations. Next is to find out Z of the circuit, impedance. How to find out impedance? So, for RC circuit, we know that impedance is R plus J minus 1 by omega c. Okay, or else mod z, if you are interested in, it is r square plus 1 by omega c whole square. Negative sign won't make much difference because we are taking square. So find out mod z. Once you have mod z calculated, you can find out IRMS. How to find out IRMS? So we know that VRMS is IRMS into mod Z. So you will get IRMS, which is VRMS 220 volt by mod Z, and that is your result 1. Once you have IRMS calculated, you can find out voltage across individual component. So voltage across resistor, VR, if we call it, VR is equal to IRMS into R. This is your second result. First result IRMS, second result voltage across resistor. Then similarly you can find out voltage across capacitor. VC is equal to IRMS into XC. What is XC? 1 upon omega C. Okay, so this is your third result, VC. Now, after carrying out calculation, you will see that this value, VR value, is around 150 volt, and this value is around 160 volt approximately. You have to carry out calculation and check exact answer. So if I sum up these two, VR plus VC, if I take, according to these values, 150 plus 160 will be around 310 volt, which is more than the supplied voltage. So VR plus VC is greater than Vrms. Now, is it logical? Because voltage is joule per coulomb, it is the energy supplied, and what this answer indicates is that the energy in the circuit is more than the energy supplied by the source. So we have created energy apparently, but it is not true. The reason is this addition itself is not allowed for such circuit. Why it is not allowed? Because if you look at the phasor of voltage across capacitor and voltage across resistor, the two phasors are mutually perpendicular. And when you have phase difference between the voltage, you cannot add. So what you have to do is, you have to apply Pythagoras theorem and you have to find out resultant voltage with this formula. Okay, so this idea is not applicable here, and hence this discrepancy is obvious. Thank you.